In this lecture, we'll show how to process elements of a list by using the for each next statement. We'll now take a look at the for each next statement. And this is another type of for loop that we can use in Visual Basic. In fact, it's very similar in structure to our traditional for loop. The only difference between the two is, remember, in our for loop, we would specify the number of iterations that the loop would have. Here, with this for each next loop, we're actually going to be looking at every single element in the list, and then we're going to store it in a new variable. So think of it as storing each element in a variable and then doing something with that variable. So let me give you the format of how we would use this loop. So we still start with the word for. It's just now we include the word each. So we have for each. That's why it's called a for each loop or for each statement. Anyway, we have this variable here called item, and this can be whatever we want. So in this case, the item here is going to be an element of my list. So we see here item as data type. So data type is going to be whatever types of elements we have in our list. And then we have the word in, and then we have my list. Now my list is another placeholder. That's just some list that we've created, and there are some elements in here. And then we have statements as part of the body of the loop, and then we have next item as the bottom part of this loop. So that means we're going to move on to the next item. So the way this is going to work is we take the first item in our list and we store it in the item. And then in the body of the loop, we're going to do something with the item, whatever it is that the loop is supposed to do. Then the next iteration, we're going to go to the next item in our list, store that in our item variable, and then do something with it. And we just keep going until we get to the end of the list. So the number of iterations is going to be the number of elements in our list. So we don't know the exact number unless we knew the size of the list. This is actually pretty much identical to the for each loop that's used in other programming languages such as Java. So this is the type of loop that we normally would want to use when we're dealing with actual lists in Visual Basic. Let's look at a simple example of using the for each loop. So what we're going to do here is we have a string str, which is initially empty, and then we have a list of integers, which is called ml. What we're going to do here is take all of the items in our list, convert them to a string, and then concatenate them together as one giant string. So we're going to have a string that contains the entire list of integers. So the main part is looking at the for each loop. So we see we have for each x as integer in ml. From our template earlier, we had item and my list. Those are just placeholders. We can use whatever variable we want and then the name of the list. So we see here that x is going to be the variable that we use in this list, and then ml is our actual list. So the idea with this is for each item that's in our list ml, we're going to store it into x, and then we're going to do something with x. And then we're going to go to the next item of the list, store it in x, and then do something with it. So what we see here is we're going to take our string, which is initially empty. We're going to concatenate a space right here. That way we can have some separation between the items. Now that does mean that when we first print the list, there's going to be a space in the front, but that's okay. There aren't any major issues with that. And then we're going to call convert.toString. So this is going to convert x, which is an integer, into a string, and then we're going to concatenate that to the end of our giant string. We'll then go to the next item in our list. So we're going to take that value, we're going to store it in x, we're going to convert that to a string, and then we're going to concatenate that and another space to the end of the current list. So by the time we get to the end of this loop, we would have our string that contains all of the items of the list separated by spaces. Now there are some limitations with using the for each loop. For instance, we're not allowed to make any changes to the elements of our list, and we can't make any actual changes to the list itself. So for example, we can't add any elements to the list. If we try to make modifications to our list in the for each loop, we're actually going to get an invalid operation exception. And that just simply means this is an operation you're not allowed to do in this part of the code. So let me give you an example here. So let's say we have a for each loop, and we're going to have our ml list of integers, and we take an item in x, And what we do inside here is just we add 5 to the end of the list. This is not going to work. We're not allowed to add anything to the list. We're not allowed to make changes in the list inside of a for each loop. We should also mention that we want to avoid actually changing the value of the variable in the loop. So in this case, we want to avoid making changes to x, because even though x corresponds to the item in the list, it's not actually the item in the list. What's happening is we take the item in the list and store it in x. So x has the value that was in the list, but it's not the actual place in the memory. So if you try to make changes to x, you're not actually changing the list. So this doesn't work. The whole purpose of this for each loop is that we can do something with the list without actually making changes to the list itself. We'll next take a look at the continue for statement. It's pretty straightforward, and I think we've even mentioned this in other types of structures, but this is equivalent to the continue statement in other languages, where if we execute this particular line, we're going to skip the remainder of the iteration. So since we're using continue for, what this means is we'll end the current iteration of the for loop, and then we'll just move on to the next iteration of the loop. I think we mentioned this before when we were talking about while loops and how we can use the continue while statement. But we can use the same thing here for loops. So this is just saying if we see this line in the body of a for loop, whether it's a typical for loop or if it's a for each loop, we end the current iteration and we just move on to the next iteration of our loop. Let's do an example of using the continue for statement, just to make sure you have a better understanding of how it works. So we'll do this as an exercise. So I will give you some code, and I'm going to ask you, what does that code do? Well, here's our code. So we have a for each loop. I want you to take a look at this, pause the video if you need to, and then see if you can figure out what's going on inside of here. And then when you think you have the answer, resume the video to see if you're right or not. All right, let's look at what's going on inside of here. We have our for each loop, and we're still using our list of integers from before, list ML. X is the variable that we're using in this for each loop. So then we have an if then statement inside here that says if x mod 2 equals 0. So if you remember, what that means is we're checking to see if the remainder of x divided by 2 is 0. Another way we could think of that is we're checking to see, is x an even number? If x is an even number, then we have the continue for line right here. So if you remember, what that means is we end the current iteration of that loop, and we're going to move on to the next iteration, which means we're going to look at the next item of the list. So another way to phrase that is, if x is an even number, we skip the rest of the iteration and move on to the next one. All right, so that means we do continue whenever we have an odd number. Well, what is going on if we have an odd number? Well, we see we have messagebox.show, so we're going to have a message box that displays some number. And specifically, it's going to be x, and we're converting it to a string because to display it has to be a string. So what this is telling us really is we're going to have a message box that displays the odd numbers. So we'll have one message box that displays the first odd number, and then another message box will display the next one. So we're going to keep displaying a message box for each odd number in our list. We also have the exit for statement. I think we mentioned the exit statement before as well, but we're just going to review it anyway. This is the equivalent to our break statements in other programming languages. And the idea with this is if we execute this line, we completely get out of the for loop. We're completely done with it. It's not enough to just say we end the current iteration. We end the current iteration and all other iterations of that loop. So think of it as just stop immediately what you're doing, get out of the loop. We then would resume with the next instruction that comes after the loop. So think of this as just like an immediate termination of the loop, and then whatever comes next is what we would do as the next instruction for our program. Let's do an example of the exit for statement, and we'll do this as an exercise. So once again, I'm going to give you some code, and I'm going to ask you, what does that code do? So here is our code right here. I want you to pause the video, look it over, hand trace if you need to, and just see what is actually happening in this particular example. Let's go ahead and break this down. So we see that we have a couple variables declared at first. We have a Boolean variable called found that's initially false. We have an integer variable called key, and it's not initialized to anything. That's fine. We have our for each loop. We have x as integer and ml. So we're still looking at a list of integers. We don't know what's in that list. We just know that we have a list of integers, and we're going to use x as our variable here. So then we have an if-then statement. So we're going to check to see if x equals key. So I think we're going to have to assume here that we set key to some value. So maybe that's what's done in the dots right here. So key is, we're going to assume that there is some value in key. So we're saying here, if x is key, then we're going to set found to true. And then we have our exit for statement right here. So what this is saying is if the value of x equals the value of key, then we say found is true, which makes it sound like we're looking for something, we found it, and then we use the exit for statement, which simply means we are done with the entire for each loop. We get out of the whole thing, and then we would just resume. Now, if x does not equal key, then we're going to go to the next iteration of our loop, which means then we would get the next value, and we store that next, and then we check to see if that's the key. So what we're doing here is we're searching our list to see if we find the value of key in the list. And if that happens, so if the value of key is found, we would stop searching. Otherwise, we would go through the entire list. So this is simply code for searching for a specific value in our list.